Finally, we had the releasing unit. So I mean, all know that the only enzyme there is thioesterase. So thioesterase loves breaking thioester bonds. This is thioester bond. So this bond here. So it'll break into your ester bond. So now we generated the last video. We generated butyryl ACP. So since we generated butyryl ACP, we can actually take this butyryl ACP to the releasing unit to be released, because the releasing unit is responsible for the release of the fatty acid generated, of the acyl group generated. Because when the acyl group, because this from here is an acyl group, so when we now add water to the help of thioesterase, that's when you now get fatty acid. So now we can't take it to thioesterase to perform those functions, because it's not up to the required carbon atom now. The required carbon atom is 16 carbon atom, so which is palmitic acid. So this is 4. So we can't take it to this to the releasing unit. ACP won't take it there because it's not up to the amount required. It's not up to palmitic acid. The major fatty acid generated synthesized in the body is palmitic acid. So ACP will not take it there. ACP knows already that this is 4. This is not up to 16 carbon units. Yeah, you know that it's not up to 16 carbon units. So now, what we're going to do is that we're going to take this butyryl ACP to condensing enzyme. Remember in the last video, I said that the condensing, when I made the video on condensing unit, I said the condensing enzyme became free when he catalyzed the reaction between the acyl group of acetyl CoA and the malonyl group of malonyl CoA. Yeah, so it was free. So we'll take it there and we'll see what happened. So let's take it to step 3. We'll go to step 3. Wait, step 3. Yes, this is step 3. So now the condensing enzyme is free here. So what we'll do, the ACP, let me represent butyryl with B. So it's a butyryl group here. So what the ACP will do, so we have condensing enzyme here that is single. So what we'll do now, we'll just give the butyryl group to the to this condensing enzyme, and the ACP will take the hydrogen. So now butyryl group will be holding the the condensing enzyme will be holding will be carrying, like to hold the butyryl group, to hold the butyryl group. So while ACP is free, ACP becomes free. Why is ACP free? ACP can now go towards the manufacturing site where malonyl CoA is manufactured. He will go and bring another malonyl CoA, so that we can add the malonyl CoA to this again, and condensing enzyme will catalyze this reaction, adding butyryl group to malonyl group of malonyl CoA. Then you now have 6 carbon unit again, 6 carbon unit now. So as you can see here, we are adding malonyl in form of 2 carbon units, but malonyl is actually a 3 carbon unit compound. But remember, it is formed from acetyl CoA and carbon dioxide. So acetyl CoA actually enters this pathway, the first cycle of the pathway, directly only once. That is here to initiate the reaction. It enters only once. So it enters only once into this pathway. So now, then the other it enters as malonyl CoA indirectly to this pathway. The rest of the cycle, it enters as malonyl CoA indirectly, because remember, malonyl CoA is formed from acetyl CoA and carbon dioxide. So as you can see here, if we are adding 2 carbon units, we are only adding 2 carbon units. Then we remove this as carbon dioxide. So it entered indirectly. So it enters directly only once. That's the first cycle. So the rest is indirectly as malonyl CoA till we get up to 16 carbon units. So now, what will happen here is that, remember, we give the butyryl group to condensing enzyme and it's holding it. So we added another malonyl CoA again. So we got 6 carbon units. So we give the 6 carbon unit. When we get to the sixth step, we will come back again and give it to condensing enzyme. We won't go to the releasing units because not up to 16 yet. We'll give it to condensing enzyme. ACP will go and get another malonyl CoA again. We add again. What do we get? 8 continuously till we get up to 16. Then when we get 16 now, since we have gotten 16 now, let's see we have gotten 16. So let's go to the releasing unit now. We go to releasing unit. Yes, this is the releasing unit. So since this is the releasing unit now, wow, we are the releasing unit. So the releasing unit, the enzyme there is called thioesterase. So this thioesterase, what it does is that I told you already, it adds water. So look at water here. We've broken it down to hydroxy group and hydrogen. So now hydrogen ion. So now we give the hydrogen to ACP. Oh, sorry, here there's a mistake here. It's supposed to be AC. So it's supposed to be ACP with an S with a sulfur showing you. So when we add the hydrogen now, you now have SH, right? So we can see we're breaking the thioester bond. We now add the hydroxy group to this ketone group. So when we give it to the ketone group, it becomes carboxylic group. So you now have the palmitic acid. You now have the palmitic acid. So you can see we get the hydroxy group to the ketone group of this acyl group. So we can see we've generated palmitic acid. This is how we generate palmitic acid. So palmitic acid is the major fatty acid synthesized in the body, and synthesis occur predominantly in the liver. This synthesis of fatty acid occur predominantly in the liver, mammary gland, kidney, so you can see, but majorly more of liver. Yeah, liver does more of the job of synthesizing. And adipose tissue too. Adipose tissue is part of it. Adipose tissue synthesized too. So now, I think we are done. We are done. So the next thing now is we're going to take on how this palmitic acid can be modified into other things. So, and I'll release a video on the regulation of this pathway, and what else again? I'll release a video on how this is formed or stored in the adipose tissue in form of triglycerides. Tag triacyl glycerol. Triacyl glycerol. How it is formed as triacyl glycerol. How it is stored as triacyl glycerol. So thanks for watching. Please subscribe and turn on the notification bell. Thank you.